students, welcome back to modeling analysis lab, and in this lab we will discuss the truss problem number 2. Here consider the 4-bar truss shown in figure. For the given data, find the stresses in each element and reaction forces in the fixed nodes, and as well as we need to determine the displacement. He has given Young's modulus as 210 GPa and A area as 0.1 meter square. Now for this problem it has 4 elements: element 1, element 2, element 3 and element 4. For these 4 elements we have key point 1, key point 2, key point 3 and key point 4. And for this one, key point 1 and key point 4 is completely constant, and key point 2 is provided with a roller, and along with this one there is an axial load of 2000 Newton and a vertical load of 2500 Newton. Now we shall solve this problem by using our ANSYS tool. Let's go for the same. Since it is a structural problem, we will select it as a structural problem and H method, select OK. In preprocessor, select what type of element. We need to add up the element, add element, link 3D finite standard 180 element. Click on OK and close it. And next one, you need to specify real constants. Real constants is nothing but the area of the truss element, and area is given as 0.1 meter square. Specify as it is 0.1 area and click on OK and close it. Next one, we need to provide material properties. To provide the material properties, we'll select material models, and it is a structural problem. Click on, and since the material is a linear material, click on it, and it is an elastic behavior material, select it, and it is a isotropic material. And for this one, he has given the Young's modulus as 210 GPa. We will be selecting 210 e power 9 Newton per meter square, and Poisson's ratio is not mentioned. We can take in between 0.26 to 0.3. We shall take as 0.3 and click on OK and close this one. Next one, we need to create the model. So we will be going for modeling, create key points, inactive coordinate system. Since key point 1 is the reference key point, x direction and y direction, we will specify it as either 0 or the same value and apply. Second key point is at a distance of 4 meter from key point 1 in x direction, and y direction it is 0. Similarly, third key point is at a distance of 4 meter in x direction from key point 1 and 3 meters at a distance 3 meters in vertical direction. Click on apply. Similarly, to select for the fourth key point is at a distance of 0, that is, it is lying exactly vertical on key point 1, and just specify y direction. This has 0 and y direction as 3 meters. Click on OK. So key point 1, key point 2, key point 3 and key point 4 has been selected. Next step is to join these key points by using lines. Set lines, and next one we'll select this straight line, key point 1 to key point 2, click on, and key point 2 to key point 3, select it, and key point 3 to key point 1, click on, and key point 3 to key point 4 and click OK. So we have created the straight lines between the key points. Next one, after creating the model, we need to go for meshing the model. So here we'll be selecting mesh attributes, and here in mesh attributes we will set manually, that is picked lines. Pick all the lines and click on OK. And so that the material is same for all the element, written as 1 and 1, and click on OK. Next one, we'll go for mesh tool, and here in the mesh tool, when the mesh tool box appears, you select it as set lines and click on all the elements and all the lines and click on OK. Here for all the truss problems, the number of element divisions you need to specify as only 1 and click on OK. Again click on mesh tool, and here you select it as a mesh and select all the lines and click on OK. So here the total model has been meshed. How we can see? Because all the lines have been turned to a bluish color, that is a light bluish color. Then the system is set, the total model has been meshed. Now we need to, after meshing, we need to apply the loads. Loads, define loads, apply structural displacement on key points. Since key point 1 and key point 2 is completely restricted to move in any direction, we will restrict for all degrees of freedom. Let key point 1 and key point 4 should be restricted, that is, we will select all degrees of freedom, click on OK. So it has been completely restricted. Similarly, key point 2 is restricted to move in only vertical direction, click on OK and select Y as well. Now after going for displacement, we will go for applying force on key points, and there is a force on key point 2 which is acting in X direction. We will be writing it as, the value it as 2000, specify the value as 2000 Newton and apply. Similarly, there is a load, vertical load, which is acting in the downward direction, so we will be selecting Fy in the downward direction, and since the load is acting downward direction, that is 2500, we will specify it as minus 2500 Newton and click on OK. So we have applied, we have constrained the model and we have applied the loads. And applying the loads, next step is to solve. We'll go for solve current LS, current load step, and click on OK. Since all the elements which are shown is correct, the system has done the solution. After getting the solution, you need to go for, to see the results. Before seeing the results, we need to go for element table, define table, add. There is nothing added, none of the element is been added. We need to add it. Select by sequence number and load step and click on 1, that is load step 1, and click on OK and close it. Next one is to see the results. We'll go for plot results, counter plot, nodal solution. Here DOF solution, displacement vector sum. So we have seen the displacement here. The maximum displacement is 0.38 into e power minus 0.6 meters. This is the maximum displacement, and minimum displacement, because of it has been restricted, it is 0. Second, after in the counter plot, we need to go for elemental solution. Stress 1 minus stress we can calculate, and line element results also we can calculate. Line element results, we can go for the maximum stress as 20,000 Newton per mm square, and minimum stress as 21,875 Newton per mm square. After selecting this one, we need to go for list results. In list results, you can either select for nodal solution, DOF solution, displacement vector sum. We will be getting the displacement in a node 2 in x direction and the displacement in node 3 in x and y direction we can have. This is the nodal solution. Next one is reaction solution at the fixed ends. See, node 1, the reaction in x direction is minus 1583.3 Newton. In y direction it is positive 312.50 Newton. Similarly, key point 4 is also fixed. It is having a resistance, that is a reaction, as minus 416.67 Newton. Total values put together is minus 2000 and plus 2500. This is the required solution we need to get. This is about the second problem. And here you need to get all this required data. Element table data also we can get. So here element 1, which is having 2000 Newton, what is the 20,000 Newton, what is the table in element stresses. Similarly in element 2, element 3 and element 4. This is about the second problem. Similarly, we go for third problem. So look into the third problem here. The third problem, we need to determine nodal displacement, stress in each element and reaction at the support. So here he has given the area of the truss element as 200 mm square and Young's modulus as 2 into 10 raised 5 Newton per mm square. So here we are having only two bar elements, 1 and 2. And here we will take key point 1 as a reference key point, and key point 2 will be, and key point 3 will be with respect to the key point 1. Now we will solve this problem by using the ANSYS tool, and that is, since he has given the data, now we will start the problem. Same thing, structural, H method, click on OK. Preprocessor, element type, add, here link 3D finite standard 180 element, click on OK and close it. Second, we need to mention the area and click on OK. Since he has given the area in terms of mm square, we will take the same values as 200 mm square and click on OK and close it. Next one is material properties, material models, structural, it is a linear member, also it is an elastic and isotropic material. He has given the Young's modulus as 2 into, that is 2 into 10 raised 5, 2e5 Newton per mm square, and Poisson's ratio you can take it as 0.26 or 27 and click on OK and close it. Next one, we need to create the model. To create the model, we will go for create key points in active coordinate system. So key point 1, we will take the key point 1 with reference as a reference key point, as key point 1 in x direction, as from the x direction it is a positive, that is 500 plus 400, it is total 900 in x direction. We will take it as and click on apply. Second key point is at a distance of 4 meters, that is 500 in x direction, click on apply. wait, we have not taken the x direction. Again we will be solving it. So after we need to remove the key points. Go for delete key points. We need to delete key point 1 and key point 2. Click on OK. And next one, same thing will be repeating again. Reference key point, inactive coordinate system. Let us write key point 1. We will take the key point 1 in x direction as 500 plus 400, that is 900 mm in x direction. Click on apply. Second key point is at a distance of, in x direction 500, in y direction it is at a distance of 300. Click on apply. And third key point, in x direction it is 0 and click in y direction it is 300. So we have key point 1, key point 2 and key point 3. And here with reference to this coordinates I am taking key point 1 in x direction, key point 2 here either I can take from key point 1 as a, that is minus 400, or with reference to this one. After creating the key points, we will create the lines. Click on the lines, straight line, key point 1 to key point 2. This is first line. Second line from key point 2 to key point 3. Click on OK. So we have created the physical model, that is key point 1, key point 2, key point 3, and line 1 and line 2. Next step, after creating the model, we need to go for meshing, mesh attributes. Go by picked lines, select line 1 and line 2. Click on OK and click OK. Next one is, we'll go for mesh tool, set lines, line 1 and line 2. Click on OK. And number of divisions we need to specify as only 1 and OK. Next one is, again re-click mesh tool, here set it as mesh, select line 1 and line 2 and click on OK. So the total physical model has been converted to FE model. The physical model has been meshed and it has been converted to FE model. Next step is to apply the boundary condition as well as the loads. See, for this problem the boundary condition is key point 1 is been completely fixed and key point 3 is also completely fixed. So we will going by applying the loads, define loads, apply structural displacement on key points. Key point 1 and key point 3 is been restricted in all degrees of freedom, so we will be selecting it as all degree of freedom OK. And key point 2, there is a load of structural, there is a load of 120 kilonewton. We will apply the same load, that is 120 into 10 raised 3. Force on key points we will be applying on this one. Since the load is acting downward direction, we will select it as Fy, and the value is minus 120 kilonewton. 120 kilonewton we applied and click on OK. So the load is acting downward direction. After applying the load, after applying the boundary condition as well as the loads, we will go for solution, solve current LS. Click on OK. Solution is done. Next we need to go for the fourth step, that is general post processor. In general post processor, select element table, define table. There is none defined, we need to add up. Here select by sequence and load step as load step 1 and click on OK and close it. Next step is to plot the results. counter plot, nodal solution, displacement vector sum. So we have determined what is the displacement. The maximum displacement is 7.12 mm and the minimum displacement is 0, and the maximum displacement is at key point 2, where you can observe here the maximum displacement. And similarly we can go for element solution, that is the stresses in the element. We can have the maximum stressor 7.12 kilonewton per meter square, and element table also we can select, so that the maximum deformation in each and the element we can determine. And line element results, we have the deformation of element 1 and element 2. After having the plot results, we will go for list results. In list results we can have the reaction solution. Select all items. So the reaction solution is in the fx direction is minus 0.16 into 10 raised 6 kilonewton, that is a Newton, and in y direction 0.126 into 10 raised 6 Newton. This is what in node 1, and similarly the values at node 3. And along with this one we can have the nodal displacement. So this is a displacement. Node 1 is completely fixed, there is no any displacement. Since node 2 there is a displacement in x direction, it is minus 2 meters, and y direction that is a minus 6.833 mm. So this is the problem. This is the problem number 3. We shall clear it. For the next problem, click on OK. Similarly, we'll go for the, we can solve the same problem by selecting key point 1, key point 2, key point 3 and key point 4. And so here is having 1, 2, 3 and 4 elements. Now look into this problem here, that is problem number 5. It is asked to determine the nodal displacement in the truss segment subjected to concentrating load as shown in figure. He has given the Young's modulus as 70 GPa and area as 0.01 meter square. Now for this problem you can see this is a key point 1, key point 2 and key point 3. This is having element 1, element 2, element 3. Key point 1 will take it as a reference. Key point 2 is at a distance of 1 meter in x direction with respect to key point 1, and key point 3 is at a distance of x direction 0, y direction as 1 meter. And key point 1 is completely restricted, all degrees of freedom. Key point 2 is been restricted in vertical direction, and here also key point 3 is restricted in x direction. So we shall solve this problem using the answers tool again. Select again the same steps. Structural, click on OK. Preprocessor, element type, add, edit, delete, add, same, click on link 3D finite standard 180 element and click on OK and close it. Next one, you need to provide the area. To provide the area, we'll go for real constant, add, edit, delete, add, click on OK. Since the area is given as in terms of meters, that is 0.01 meters, select as it is and close it. Next one is you need to specify the material properties, that is material models. Click on structural, linear, elastic, isotropic, and here he has given the Young's modulus as 70 GPa. The same thing will be taking 70 e power 9 Newton per meter square, and Poisson's ratio 0.26 or 0.28 we can specify and click on OK. Next one is to create the modeling, create key points in active coordinate system. We will take the key point 1 as the reference key point. In x direction it is 0, in y direction so it is 0. Click on apply. Similarly, second key point is at a distance of 1 meter in x direction and 0 meters in y direction. Click on apply. Similarly, third key point, in x direction it is at distance of 0, in y direction is at distance of 1 meter. Click on OK. So key point 1, key point 2 and key point 3 has been created. Now we need to join these key points by using the line elements. Create lines, straight line, join key point 1 to key point 2 and key point 2 to key point 3 and key point 3 to key point 4. Click on OK. So here element 1, that is the first line, second line and third line. After creating the model, we need to mesh the model. For the meshing the model, we'll go for mesh attributes, picked lines. Here we can select manually, that is picked lines. Pick all the lines and click on OK. Now here, since the material is same for all the lines, we will be specifying the same as 1 and 1 and click on OK. Next step is select mesh tool. You select it as a set lines and click on the 3 lines and click on OK. Now for all the truss problems, here also we need to specify number of divisions as only 1. Same again, repeat mesh tool. You click on for the mesh, select all the lines, so that all the lines should be having the same light bluish color. So this is what we have done, the meshing for the physical model and converted the physical model to finite element model. Next step is to apply the loads. Before applying the loads, we need to constrain it, that is define loads, apply structural displacement. Since key point 1 is been restricted in all directions, we'll go for key point on key points. Key point 1 will be giving all degrees of freedom as 0, that is all degrees of freedom is been restricted. Key point 2 is restricted in y direction. Click on uy and select OK. And key point 3 is restricted in x direction. Click on ux, only ux and click on OK. So it has been restricted in y direction. Now we need to apply the physical load, that is define loads again. Apply structural force. So he has applied the force at key point 2 and key point 3. At key point 2 is a negative key point 2, in x direction there is a load of 100 Newton, in leftward direction, so we will take it as minus 100 and click on OK. Similarly, on key point 3 there is a vertical load which is acting in upward direction, so we will be considered as a tensile of plus 200 Newton and click on OK. Now we applied the physical loads and we have constrained, and we shall go for solution, solve solution, solve current ls and click on. The solution is done. Next step is to go for general post processor. In general post processor we need to go for element table, define table. Here none is been defined. We need to add up, scroll it downwards so that by sequence method, and load step as 1 and click on OK and close it. Next step we need to go for plot results, deformed. Either you can go for contour plot, modal solution, displacement vector sum. So the displacement is 0.256 e power minus 06, that is in terms of meters. And elemental solution, you can have the 1 minus trusses, and here the line element results also we can get, that is here the maximum displacement and maximum stresses developed in the element 3, we can select it, and after that we will go for the same thing, list results, nodal solution, displacement vector sum. Node 1 is completely fixed, there is no any displacement. Now node 2 is having a x direction displacement and node 3 is having a y direction displacement of these values. And along with this one you can have the elemental solution in the 1 minus stress also we can calculate. These are the element 1, element 2 and element 3 values we can find out. And here the major thing we need to select for reaction solution, you select for all. So the node 1 in x direction it is having a resistance of 120.71 Newton, in y direction minus 179.29 Newton. Similarly second node is having in y direction as minus 20.717. So here one thing is that when we add up all these things it should be equivalent to the applied load, then only your problem is correct. So here this is the solution and reaction solution for the problem, and this completes your all the truss problems. And for practice you can take the reference textbooks and you can practice for the different problems. Okay.